In this video lecture, we're going to discuss how to integrate the secant in the cube, which doesn't really fit to any integration techniques. So in order to integrate this, we're going to use the integration by parts method. In order to do this, we first of all are going to write down the secant in the cube as the secant of x multiplied to the secant in the square of x dx. And here we need to substitute something as the u, something which we can take the derivative. So here I can take the derivative of the secant. So that's why the u is going to be equal to secant of x. dv is going to be equal to the secant in the square of x dx. So the derivative of the secant is equal to secant multiplied to the tangent of x dx. And the antiderivative of the secant square is the tangent, because we know that the derivative of the tangent is equal to the secant in the square. The derivative of the tangent is 1 over cosine square of x. So the v is going to be equal to the tangent of x. So according to the integration by parts method, I need to multiply this u to the v, then v to the du. So let me multiply this. It's going to be secant of x multiplied to the tangent of x minus the integration of v du. In this case, it's going to be tangent of x multiplied to the secant of x multiplied to the tangent of x dx. Okay, so here you might see that I'm going to have the tangent in the square, right? So we can write down actually tangent in the square in terms of the secant. The tangent in the square is equal to 1, I think it should be 1, or secant in the square minus 1. Secant in the square of x minus 1, right? So let's check that. Secant in the square is 1 over cosine square of x minus 1. So if you give the common denominator, it's going to be 1 minus cosine square, which is sine square, divided to the cosine square. So sine square of x divided to the cosine square of x. So it's true that the tangent square of x is equal to the secant square of x minus 1. So I'm going to just substitute this here. So it is going to be equal to secant of x multiplied to the tangent of x minus the integration of secant square of x minus 1, this is the tangent square, multiplied additionally to the secant of x dx. So we can open up the brackets. It's going to be a secant of x multiplied to the tangent of x minus the integration of the secant cube of x dx minus the, or in this case it's going to be plus the integration of the secant of x dx. At the first glance, you might think that we are stuck because we've got the two more integration which were even more difficult for us to integrate. But let's remember what we have started with. So we started with this integration. The integration of the secant cube is equal to all of these terms, right? So this is actually equal to the secant in the cube. So this is, so is it possible to do? Sorry. So this is equal to the integration of the secant cube of x, right? So what we can do is I can just put the secant cube to the left hand side, and what I'm going to have here is 2 multiplied to the integration of the secant cube of x dx is equal to the secant of x multiplied to the tangent of x. Then we need to use the formula for the integration of the secant, which is going to be equal to the ln of tangent of x plus secant of x. Then the integration of the secant cube of x is going, dx is going to be equal to the 1 over 2 multiplied to the secant of x multiplied to the tangent of x plus ln of tangent of x plus secant of x plus the constant. So this is how we can integrate the secant in the cube.